in this question, they give you the distribution of the age of children in a group. At the same time, they give us some constraint. A is larger than 11 is because from the graph we know that A is taller than 11. And then B, that means this bar is between 4 and 11. So the most important thing is they give you about the median so that you can sort out some possible solution. Median is 7.5, not 7, not 8, which means that the number is separated to two parts. The first half, the second half. And then they have the same number of data such that we will use the middle number between 7 and 8 to represent the median. So based on this, the conclusion we can write is 11 plus A should equal to 11 plus B plus 4. It gives us an equation, and then we can find out some combination for A and B, which means A is equal to B plus 4. After we have the equation, we try to list out some combination. Maybe we start from B is because B is the input and A is the output here. So for B, the first possible value for B is 5, 6, 7, something like that. So it can be 5, 6, 7, 8, 9, but it can't be 10. The corresponding value of A, if B is 5, then A will be 5 plus 4, which gives us 9. So if B is 6, then A is equal to 10, 11, 12, 13. We also need to consider the constraint for A. A should be larger than 11. So 9, 10, 11 are all unacceptable. This is rejected. So we have two combinations fulfill our requirement. And we don't have any other method to exclude anyone, and you have to accept we have two solutions to satisfy the same condition here. That's why we draw our conclusion. A is equal to 12, B is equal to 8. Or the second case, A is equal to 13, while B is equal to 9. Beware that you must write down this symbol. This symbol means n, so we know this is one group of data. And or the second case is like this. It's totally fine that we have more than one solution to fulfill the requirement. That's our answer for part A. And then in part B, they say that now there are 4 more children join the group. They are all different value, and the range of the age of the children are unchanged, which means that the new age can be 5, it can be 11. And then they ask you two separate questions. The greatest possible median. So for greatest possible median, we prefer a bigger value of their age for the new members, which means that the new added children, their age should be 7, 8, 9, and 10 because they should be all different. We have two cases, so we have to think independently, case by case. Case 1, we assume that A is equal to 12 and B is equal to 8. In this situation, the new median. Original is in the middle. Now we have 3 more to second half, so it should be 8 now. Another case, is also 8. So the greatest possible. Median is 8. Basically, in these two different situations, they both give you the same value of the median. Just more secure to think case by case. And then in part B2, they ask you about least possible mean. So we just simply use the same logic. This time for the least possible mean, we prefer the 4 new children age are as small as possible. So 6, 7, 8, and 9. And also we have two different cases, so we have to calculate case by case and see which one is the smallest. Case 1. A is equal to 12 while B is equal to 8. So the new mean is equal to A is 12, B is 8, so it's become 12, 13, 12, and 9 because we add 4 new members. So it is equal to H is 6 appear 12 times, 7 appear 13 times, 8 appear 12 times, appear 9 times, and finally 10 appear 4 times. Divided by the total number is 12 plus 13 plus 12 plus 9 plus 4. Then the new mean is 7.6. We finish one case, we are going to continue repeat the same thing for another case. If A is equal to 13, B is equal to 9. So this is 13 and 9, so the new number is 7 appear 14 times, 9 appear 10 times after we add 4 new children. So 6 appear 12 times, 7 appear 14 times in this case, 8 appear 12 times, 9 appear 10 times, 10 appear 4 times. The total number of children, 12 plus 14 plus 12 plus 10 plus 4, is equal to 7.615 something something. So this is smaller, so our least possible. We draw our conclusion now. Least possible mean is equal to 7.6. A very important thing is in this question is you have to think what kind of data favorable to your outcome. For example, greatest possible median, then we will assign them to 7, 8, 9, and 10. Each of them we assign 1 because they say that they are all different. Another thing is because from the very beginning we don't have the confirmed value for A and B, so we have every time we have to consider 2 different cases and then run through them one by one and then make our final conclusion afterward.